we'll be working with a function f that we're told has derivatives of all orders at x equals 0. And as the problem progresses, about which they tell us more and more information about the function and its derivatives at x equals 0. This is fundamentally an nth degree Taylor polynomial problem. And at the end of it, we have to be particularly careful about how we apply the chain rule. So I've included that relevant information over here on the right. So part A gives us, they say, given that we know that f of 0 equals -4, I'm just repeating that, and this very specific information that the first degree Taylor polynomial about x equals 0 for x equals 1/2 is exactly -3. Given that, we have to show that f prime of 0 equals 2. The key is we write out what the general first degree Taylor polynomial is, and then insert this pair of values, the 1/2 and the -3, and then work backwards to solve for f prime of 0. So P1 of 1/2 is this first degree Taylor polynomial described here, where a is 0. And so that's f of 0 plus f prime of 0 times x minus 0 in this expression. But since a is 0, it's just multiplied by x. Okay, where x is 1/2. So we know that. We also know what f of 0 is. We know that it's -4. And we know that P1 of 1/2 is given as -3. So we have a -3 equals -4 plus the quantity that we don't know times 1/2. Add 4 to both sides and we get, and then we multiply both sides by 2. And from that we get that 2 equals f prime of 0. Part B, they give us a little bit more information. So we've already been given this information and this. Now in part B they tell us these 2 additional facts and ask us to write out P sub 3 of x. So the third degree Taylor polynomial of this function about x equals 0. So we're just going to write that out. We have P sub 3 of x is, by its definition, f at 0 plus f prime at 0 times x minus 0, which is simply x, plus 1/2, this is really 1 over 2 factorial, f double prime of 0, and then we multiply by x minus 0, the quantity squared, and then plus 1/6, which is really 3 factorial, f triple prime of 0, we're getting a little carried away with how many marks we put up here, times x minus 0 cubed. Now we can start to fill in the numbers that we have. They don't give us any additional information for this because this is a variable expression, a functional expression. But what we do know is f of 0 is -4. F prime of 0 is 2. F double prime of 0 is given as -2/3. And f triple prime of 0 is given as 1/3. Okay. So we have to combine this. Let's just say thus. P sub 3 of x equals -4 plus 2x Now we're going to combine these two coefficients, minus 1/3 x squared, and we'll combine these coefficients, plus 1/18 x cubed. As simple as that. Now we turn to part C. Here, they're going to give us a new function, h of x. Well, what do we know about h of x? We know that h of x is such that h prime of x equals f of 2x. And we also know that h of 0 equals 7. What we have to show or find, okay, is what I'm going to call h3 of x, namely the third degree Taylor polynomial of h of x about x equals 0. Well, third degree Taylor polynomial, that's going to be, so I'm going to say that h3 of x equals, again I'm working from this definition where a is 0 and f is now h. So it's h of 0 plus h prime of 0 times x plus 1/2 h double prime times x squared plus 1/6 h triple prime times x cubed. So now we have to find each of these respective values. So let's take a look at that. So this is C continued. H of 0 we've been given as 7, so that takes care of that. What about h prime of 0? Well, that means f of 2x at x equals 0. Well, when x is 0, 2x is 0, and so this is asking us about f of 0. F of 0 we already know. It's -4. So that takes care of that. How do we find h double prime of 0? H double prime of 0 must be the derivative with respect to x of f of 2x. This is simply another way of saying that since h prime of 0 is f of 2x, h double prime of 0 must be the derivative of f of 2x. Now we have to think carefully about the chain rule, which tells us that first we have to differentiate the entire expression with respect to the inner function, and then multiply it by the derivative of the inner function with respect to x. In this case, that means we're taking the derivative of f of 2x with respect to 2x times the derivative of 2x with respect to x. Well, the derivative of f of 2x with respect to 2x, and again, that's at, all of this has to be calculated at x equals 0. Derivative of f of 2x with respect to 2x, that's the same as the derivative of f of something with respect to that same something. That's what we mean by f prime of x. We're going to evaluate that at 0. So we put a 0 in here, we get 0. And what do we know about f prime of x? Well, we know that it equals 2 when x is 0. So that's that. This derivative is just another 2. So what we have is that h double prime of 0 equals 4. Our last calculation is for h triple prime of 0. That means that we're going to have to take the derivative of this expression again. So we're talking about the derivative with respect to x of the derivative with respect to x of f of 2x. And once we've taken all of the symbolic derivatives applying the chain rule, then and only then at the end will we apply the condition that x equals 0. What we learned when we took this derivative previously by the chain rule is that it was 2 times the derivative of f of 2x with respect to 2x. And so we're being asked to take that derivative. Well, the 2 comes out, and then we're going to apply the x equals 0 condition. The 2 comes out, and so we have the derivative with respect to x of this expression. Okay? But even this expression, we cannot take this derivative directly, but rather we have to take it using the chain rule. And so it's 2 times the derivative with respect to 2x of the derivative of f of 2x with respect to 2x. And then we have to take the derivative of 2x with respect to x. That's kind of a messy looking thing, but the fact that we're going to apply now at the very end the condition x equals 0 is going to help us out. So first of all, the derivative of 2x with respect to x is 2 regardless of whether x is 0 or not. Okay. This expression here is what we mean by the second derivative, f of 2x with respect to 2x. And we're going to apply that condition x equals 0. What do we know about the second derivative of f with respect to its input? What we know is, I'm sorry, I should actually write this as this. What we know is that the second derivative of f of its input with respect to its input when x is 0 is f prime of 0 negative 2/3. I say when x is 0, but what's key is x is 0 and therefore 2x is 0. Long story short, this equals 2 times 2. This itself is negative 2/3. And so the entire expression, this whole mess here, is negative 8/3. Now we can put everything together. h3 of x is 7 minus 4 times x plus, what did we find for h double prime of 0? 4. But we multiply that by a half. 4 over 2 is 2. And what's our last? 1/6 of h triple prime of 0. h triple prime of 0 is negative 8/3. That'll be negative 8/18 x cubed. And what do we know about 8 over 18? Well, we can simplify that just one more step as 4 over 9.